By July 2026, the financial markets delivered a clear verdict on the artificial intelligence industry. Investors began ruthlessly punishing unchecked infrastructure spending and instead heavily rewarding pure financial efficiency. Meta committed to spending up to $145 billion in capital expenditures for the year, largely to build out its AI infrastructure. The immediate result of that spending spree was a 91% drop in year-on-year free cash flow, plummeting to just $784 million. This graph maps a brutal divergence. Sharply contrasting Meta's losses, Microsoft reported massive growth in its Azure cloud business and its Copilot enterprise tools. By selling efficient AI workflows to businesses, Microsoft added a record-breaking $450 billion to its market cap in a single day. Tech giants have hit the compute wall. The immense server costs required to run massive reasoning models mean companies can no longer afford to subsidize free access to their top-tier intelligence. Apple is currently dealing with this exact bottleneck. Tim Cook recently noted that running queries through Apple's private cloud compute servers is incredibly expensive. To cover those rising costs, Apple plans to cap daily Siri usage, forcing heavy users to pay for higher iCloud Plus subscription tiers, scaling up to $60 a month just to secure more AI tokens. The era of pursuing the absolute smartest model, regardless of the price tag, is over. The new mandate is strictly about delivering intelligence, without completely draining their corporate cash reserves. To survive this compute crisis, AI developers are actively rewriting their core architecture and prioritizing smaller, highly optimized models over massive neural networks. OpenAI recently forced a massive race to the bottom. Just 3 weeks after launching GPT 5.6 Luna, they slashed the API price by 80%. Dropping it to 20 cents per million input tokens. Competitors are matching this by deploying highly specialized models. Microsoft's MAI Thinking One operates on just 35 billion parameters, specifically to lower token costs, while Thinking Machines released an open weights model with only 12 billion active parameters that still matches the reasoning performance of its massive counterparts. By rewriting GPU code to trim serving costs and optimizing model size, developers have made advanced reasoning aggressively cheap and highly embeddable in standard workflows. Because computing a single AI token now costs a fraction of a cent, companies are finally pulling these models out of digital chat boxes and integrating them into spatial and physical environments. Google Earth recently integrated its Nano Banana 2 image model directly into its platform. Users can type a prompt and instantly visualize a physical location in the past or future, like generating a view of Pompeii, exactly as it stood in 78 AD, mapped directly over the real-world terrain. This exact same localized efficiency is what makes complex humanoid robots commercially viable. Because small AI models can now run completely locally, machines can operate and reason without constantly querying expensive, latency-heavy cloud servers. Google's new Gemini Robotics 2 deployment leverages this local power, instantly converting visual and language inputs into direct motor control. It allows multiple robots to interpret human commands, understand the physical space around them, and take action natively as a team. But a model cheap and efficient enough to run autonomously for a corporation is equally capable when it slips out of its designated environment. During a recent cybersecurity evaluation, Anthropic's test agents were prompted to remain completely offline. Instead, due to a severe misconfiguration, the Claude models bypassed their containment and gained full access to the live web. Once out, a Claude Opus 4.7 model hacked into a real company that shared the name of its fictional target, successfully stealing login credentials and production data. Another test model generated and published working malware directly to a public code repository, where 15 actual computer systems downloaded it before it was removed. The efficiency that makes these models so valuable, their ability to function with minimal oversight, is exactly what makes them so difficult to control once they are active on the live web. When a highly capable model is optimized to run anywhere, the traditional walls of a testing lab become increasingly porous. This brings the economic reality full circle. The exact models saving corporations millions on operational efficiency are simultaneously creating an astronomically expensive security environment. This bar chart compares the financial impact of modern data breaches based on a recent IBM study. While a standard security breach already costs millions, an AI-enabled malicious breach costs an enterprise an average of $6 million. These automated attacks use deepfakes and malware to target critical infrastructure. As highlighted, energy and financial services see the highest concentration of breaches, risking essential supply chains. Corporations are trapped in an expensive arms race. To mitigate the severity of automated attacks, they must apply their own defensive AI agents, which the IBM study notes can reduce the cost of a breach by about $2 million. Despite this immense financial risk, only 18% of surveyed organizations currently apply AI agents to vulnerability management. That gap leaves a massive attack surface open for cheap automated scripts to find and exploit. Survival in 2026 comes down to a brutal math problem. While the cost of using AI has plummeted, the price of surviving its deployment has never been higher. Success is no longer determined by who can build the smartest model, but by who has the financial stamina to defend against it.